everybody online. Can you hear me okay? We've got a good turnout today, a little bit better, not Bruce by himself like some of the last meetings that we've seen, Bruce on camera here. But we've got 8 of us here present, 9 including, or 10 including me and Amerigo. And look forward to having more people attend. We've got some breakfast sandwiches today, but if we get more of an attendance, we'll get some bacon and eggs, right? All right, with that, I'd like to do a quick introduction of the people that are here. I'm Greg Froelich with EPS Group.
I'm Rob Hussey. I'm a landscape designer and project manager at the Flood Control District of Maricopa County.
Rick Katsachik with HDR.
Kevin Roberts with Dibble.
Bruce Kay with Mignon and Moore.
Mike James with SIPTAC.
Justin Gutierrez with McDot.
Steve Wilcox.
Okay, thank you very much. And with that, we'll start our presentation. I know we're running a couple minutes late because of some IT issues. The cats here weren't doing their job, so we need to get that going. And we've got Rob Hussey presenting today from Flood Control District.
Thank you, Greg.
Clicker.
Stand over here. Can they see me on the camera still?
Yes.
Okay. Yeah. All right. Good morning, everyone. Thanks for having me. I'm Rob Hussey with the Flood Control District. So my focus there, and I've been there for about 3 years, has been a lot of this project, the Durango Campus Landscape and Water Conservation Retrofit. I work as part of a smaller branch or department at the district, which is the Landscape Architecture Water Conservation branch. So it's me, my supervisor is Harry Cooper. Some of you may work with him every once in a while. He's a landscape architect, and then we have a tall pot tree nursery, which I'll talk about a little bit more in the presentation here, as well as a water resources staff member who's looking at recharge opportunities on district structures. So I've been at the district for about 3 years. Like I said, a lot of that focus has been the various stages of this project that I'm going to talk about here today. Just quickly, some context. The project itself is at the district's office building property. So we have our administration office building. It's 2801 West Durango Street. We also have an operations and maintenance yard as part of that property. We're surrounded by other county properties. That's McDot is kind of the mirror image across the street. And then you can see kind of on the southern half of the property also is our tall pot tree nursery. 27th Avenue and Durango are the major cross streets. So we're 4 or 5 miles from downtown Phoenix. Here's kind of an oblique view of the campus. Like I said, admin building, the O&M building. You can just to familiarize ourselves with the site a little bit. For the sake of the presentation. Oh. Keeping us safe. But just for the sake of the rest of the presentation, to familiarize ourselves, if you drew a line from kind of the corner at Durango Street, the sort of the nose of the admin building diagonally through the property, those are kind of the 2 watersheds, if you will, of the project, with the rooftop of the admin building behaving that same way, kind of split in half along that axis. And then the large basin that you see next to the admin building along Esterbrookes Boulevard, as well as a basin along Durango Street. Between the building and Durango Street are kind of our 100-year flood protection. So then just to kind of give a little bit of a more of an introduction on the project, and the reasoning behind it is part of the district's mission statement is to recognize stormwater as a resource for the long-term benefit of the community and our environment. And it goes on to speak about protect against the loss of life and property. but that's kind of the focus of these types of projects and why we're looking at doing more work like this. And we, of course, manage a significant portion of water that falls on Maricopa County. So I like to think it puts us in a unique position to manage stormwater responsibly, reuse it if possible. And in this case, use it on landscape or replacing potable water use for landscaping. So obviously these two photos are very different scales that I'm showing here, serving different purposes, but it's the idea behind treating it as a resource and watering plants with it versus treating it as a nuisance. So the picture on the right is a photo of the visitor entrance at the admin building that was done as kind of an example project 4 or 5 years ago. And then the other piece that led us to kind of the opportunity to do this project is just the need for a landscape update. McDOT just got done with theirs actually, so the timing is kind of the same. So the irrigation system is requiring almost constant repair, and the percentage of trees and shrubs and ground covers left from, if you compare it to the as-built, is like a very small fraction of plant material left on site from construction in the 90s. So the whole conversation began with a master plan done by the person in my position before I came to the district. Her name was Kaylee Coulter. And so that's what kind of got the ball rolling. The focus here was to kind of fit as many GILID, green infrastructure, low impact development features on the site as possible. And it was kind of, or they were thinking about it in a way where we would use our own resources most likely to kind of construct things bit by bit as funds became available or as somebody had time to kind of take that work on. And so it was going to end up being kind of piecemeal, but it still would have provided this valuable sort of resource or showcase. And this project also set the goals that have guided the project since then. So we want to reduce potable water use for irrigation by at least 50%, better manage stormwater as a resource using GILID techniques, and then we want it to be an educational showcase. And there are some additional goals that go along, especially with kind of 2 and 3, where part of the stormwater management and educational showcase is that we'd like to, or one of the things we'd like to showcase is how you can use GILID as a primary or supplemental source of actual flood control work. So the benefits that you hear about, like saving water on other infrastructure, if we were to use this more dispersed capture method, capturing water higher in the watershed, utilizing it there, in this case for landscape. So just kind of following that timeline, my first effort on the project in 2019 was the feasibility and costing analysis, which was done with J2 Engineering. And so this shifted the focus a little bit more to a comprehensive site plan and strategy where we were looking at optimizing capture of stormwater throughout the property. So how much can we truly reduce potable water use for irrigation by taking the water that falls on the site and actually just kind of spread it out as much as possible? It's sort of a unique scenario where we're talking about it a little bit in terms of flood control, like I mentioned, but because we have the 100-year basins on site, there's not any imminent problem flood control wise, but we do want to sort of assess how effectively we're taking water out of this sort of miniature system of watershed using GILID within the parking lot. So this project started to look at that, and now we're starting to think about how it would be bid out and constructed. So fast forward to today, we're wrapping up final construction documents. And so for the second half of the presentation, we'll talk about some of the more technical things that we got into with EPG is leading the project, John Griffin with EPG. And he's being supported by Work Urban Design. Jesse Westad and Brian Sager are doing a lot of the work with some of the cisterns and all the piping that involves. And then we have Kinley Horn doing civil, structural, electrical. Yeah, so the other things I'll highlight is some of the data-driven design work that we did, some of the analyses that informed our decision-making. And then, like I mentioned, that data-driven design informed the way that we were really able to kind of fine-tune the optimization effort, how we're going to spread water out and use less potable water, capture more in the upper watershed. And then I'll talk a little bit more about the education aspect, and we plan on monitoring the project after construction to collect data so that we can kind of provide that to practitioners and hopefully see more projects like this in the future, kind of make it easier for others. So the first piece of data-driven design to talk about is a water budgeting exercise that we did. So early on in the construction document process, we created sort of a representative planting plan, created with the plant material and densities that we knew we were going to be comfortable with moving forward. And that sort of schematic plan allowed us to use average plant demand and that density and get a good idea of how much water the site was going to need and then this is on a monthly basis, based on how evapotranspiration changes with the temperature and humidity. And then beyond that, there's a rain gauge on site, so we know how much water is available to us every year. And then we were tinkering with how much cistern capture we would like to do. So those were kind of all the factors that we were looking at and seeing how much potable water we could actually offset. The current demand annually is about 1.3 million gallons of water, and we think we can cut that in half at least. The other big factors here are a strictly Sonoran adapted plant palette, and then a smart irrigation system with sort of moisture sensors that will keep the system off when the soil is wet enough that the plants don't need additional water. And then the passive capture portion where we're collecting water in basins and swales or through permeable pavers. We essentially used sort of a coefficient to represent how that offsets potable water use. So you sort of look at it like half of the actual water that shows up there counts as irrigation. We ran a PC swim model for the site, so this kind of goes hand in hand with the water budgeting exercise. Like you can kind of see here how it's split in half. That line through the admin building shows how the site is split in half, or at least that axis. And water is flowing to two locations within the parking lot. There's a catch basin and great inlet here, and then sort of a routed riprap scupper on the other end of the parking lot. And so we had our 30% design or 45% design. And you can see the red outlines are the features. So here we have permeable pavers. This parking row is going to be replaced by a swale for collection. And so this sort of half of the parking lot, you have this treatment train of features where water is going to continually get picked up. And the goal that we set for ourselves was 1 inch of rainfall collected. So essentially, we could get an inch of rain on site, and no runoff would end up reaching either of those sort of parking lot outfall points. 1 inch we decided on because it's going to capture the vast majority of storms here, and we felt like it was an achievable number. Part of that was an analysis, sort of a cost benefit analysis that we did for cistern capture on site. And we found that it became sort of cost prohibitive once we went over 1 inch of cumulative capture from all the rooftop spaces on site. So I think I have a few more slides on it, but essentially we're looking at capturing water active capture, so in cisterns to be hooked into the irrigation system from all the, or almost all of the rooftop spaces on site, the entire admin building, all of the parking shade structures, and then a portion of the O&M building down here already drains into some landscape space. So that's kind of more of a passive system, but we're going to connect a tank to another portion of the O&M building rooftop as well. So that gives us a total capture of something like 50,000 gallons. And the idea there is the rainy, hot season in the middle of the summer, the soil moisture sensors keep the irrigation system off sometimes. Plant material is hardy enough to survive through some of those hot periods with less water than a typical commercial landscape. And then when it does need water again, we have water in tanks, and it's too dry here to make it through that entire dry spell that we get with cistern capture, but it definitely sort of flattens that demand curve each year. So sorry, back a little bit of a tangent there. Back to the PC swim model. We ran this with an earlier design iteration, and then it informed, I think, going into our 90% plans, we found that this side was capturing, it was overbuilt or over-designed. So, for example, we reduced the amount of permeable pavers on this side because they were too efficient, and we weren't proposing as many features over here. So kind of money-wise or construction estimate-wise, we were able to flip some of the costs to that side as well as more capture to balance things out and hopefully achieve more success with the landscape across the site. And then, like I mentioned, a whole bunch less water or no water, depending on the size of the storm, would reach those big basins next to the administration building. And so this is, I can't remember which storm this is modeled after, but you can see the blue line is the runoff ending up in those basins pre-construction, and the gray line is post-construction, the estimate of what would end up in. So a little bit more about some of the features that we're looking at. The parking lot, we're trading a decent amount, but we studied it, a decent amount of parking spaces for new landscape areas. So like many parking lots, it's a little bit over-designed or oversized quantity-wise. So we looked at if the admin building was completely full of staff, how many spaces would we need? And we found that we were kind of right around that number where we would definitely be okay to reduce parking. So part of it is just a reduction in parking, creating additional landscape space so we have space to collect stormwater. But then there's some more highly engineered features like this schematic detail that you see here, where we're installing permeable pavers. I believe it's paved drain in our specs right now, over silvicels. So if you're not familiar with silvicels, it's a structural component, these sort of grate-like features that provide the structural support to a pavement or parking lot. And you could put it right in a drive aisle if you wanted to. We're choosing to do it under parking stalls. The pavers will function better that way. But because the silvicels provides the structural support, you don't have to compact the soil to 95%, and a tree is going to grow much, much better in that space. So those benefits add up over time where you're cooling off the site by providing that tree with the room to grow and be successful. And it will be passively irrigated fairly often, or more often than it would be otherwise, of course, because of the permeable paver system over the top. You can see here, and if we flipped back to that early slide, the oblique of the campus, it's a stark contrast, right? But this row up towards the building, that's a full row of parking that will be replaced. So that collects stormwater. You can see the permeable pavers. This remains largely the same with just some spaces kind of replaced by landscape. Here's the latest detail of the Silva cells. We're actually, I mentioned how we redesigned going into 90%. The one side of the parking lot was over designed. So we only have permeable pavers on the north side of that planting strip with the Silva cells now. Because that's where the water's coming from to start with. So we kind of reduce some costs by we'll just have asphalt on the south side, and any water that does kind of escape that portion of the system just continues on to the next swale. And then I mentioned some of the cisterns. It's hard to see in this. We don't have a great rendering that shows one. There's a cistern here on the admin building, but there are going to be 4 10,000-gallon buried tanks, a 4,000-gallon above ground tank near the O&M building, and then just a couple others near the entrances to the admin building, sort of as that visible reminder, part of the educational showcase to show where we're capturing water. The pipes coming, the big tanks coming off the admin building is going to be a fairly simple exercise of reconnecting a piece of PVC pipe and just running it to the place we want it to go. And then, like I mentioned, all of those are hooked into the smart irrigation system. And the controller is pretty sophisticated. So we'll have a lot of control over when basically just when we're able to pull from cisterns rather than using the potable line. And like I mentioned, almost all of the roof structure is being captured in cisterns. I thought this was, and it's not showing up perfectly, but we're installing gutters on the parking lot shade structures, and then it's kind of work did a really good job of looking at this detail again and again to make it as clean and organized looking as possible. But there's a lot of pipes going on from gutters down to the structural support of the parking shade structures and then into the parking lot and then some of the plumbing that goes along with that to get water to cisterns. So PVC is running up the costs a little bit on the project, but it's just part of it. Comes with the territory. And then a schematic of or an elevation of the O&M building. So we're looking west in this photo where these scuppers off the rooftop are existing, and right now they just spill out onto the parking lot and off to a storm drain. So we're just kind of intercepting that water and piping it along to a tank there. That tank actually, we just recently decided to have that work as a more passive system, where it's sort of right in between passive and active, where it's going to be gravity fed, so it's not hooked into the irrigation system. But we're kind of going to designate that to water just a certain area of campus. So there's kind of this hierarchy of active to passive, and it all relates to the value of the landscape that we're looking to get out of it. And then I mentioned before, a really big part of us trying to achieve our goals is just the use of native plants. Part of that is our tall pot tree nursery. So I'll do a plug here for ACEC, our tall pot tree coordinator. We grow native trees from seed in 3 foot tall by 6 inch PVC pipes, and then you water them only as much as they need to be, and it promotes growth of a taproot. So you take these out on a project, they already have a 3 foot long taproot, drop it into the ground. And I believe we're getting like a 70 to 80% survival rate. We're going to put some in on this project and irrigate some, not irrigate others. It'll be interesting to see how the non-irrigated tall pot trees do in a more urban environment, because we're obviously typically taking these out on restoration projects in the desert. So slightly less harsh conditions, but they're still surviving out there without irrigation. I think generally you find that these trees will catch up to a 24-inch box 3 to 5 years after. If they were planted next to each other in 3 to 5 years, they look similar. A tall pot tree might look better because the roots just are that much more established. And then other planting strategies like hydro seeding, and we kind of thought about planting design as almost like a series of concentric circles going out from the admin building entrances, where we're comfortable using a little bit more water closer to the entrance for the more high value landscape, slightly more formal looking, but still this sort of naturalized look. And then moving out, kind of going more towards a restoration or revegetation type techniques. We plan on watering some of the spaces only for establishment, so just adding a few more valves here and there. Somewhere where it's going to be mostly hydro seed and tall pots, we can switch that valve off after we irrigate it for a year, and it should be okay. And then the baseline irrigation system, baseline being the brand name. That controller is fairly sophisticated. Those soil moisture sensors, I think we're going to put 25 of them out on the project, and we've put a good amount of thought into exactly where we want those sensors to go to achieve. We don't want to leave plants too dried out for too long, but we would like to be on the side of watering less, and we feel confident about that just because of the type of plants that we're going to put out on the project. So the location of the sensors within a swale or a basin is going to be interesting to see how that plays out and how we can control the system that way. And then just a few other interesting features that we're going to put in. We're going to collect runoff from Durango Street, actually. So we're going through a City of Phoenix permitting. There's an IGA with the city, actually, so it's not a full site plan thing with them, but just to get the streets work done. So you can see we're going to let water through the curb. This is a mag detail for a scupper under the sidewalk into a swale, and then sort of a miniature concrete dip crossing that's going to let water into our 100-year basin, on the theory that we have the additional capacity because none of the water from our parking lot, or very little depending on the storm, will be ending up in those basins. And you can see that in the section here, the scupper under the sidewalk. The trail is going to be a big improvement on site. That's currently down in the bottom of those basins, so it's all mucky right now. The surface is kind of less user-friendly to start with, so we're going to bring it up so it's high and dry and stabilized decomposed granite, so just a much more pleasant user-friendly experience there. And then we're looking at creating some additional landscape space on Esterbrook's, and I don't know if this is news to the MCDOT participants we have today, but essentially northbound on Esterbrook's Boulevard, there's space for 3 lanes, but the middle one you can see in this photo is just sort of a painted median. So our thought, and the trees are no longer in the plans, but our thought is to create some additional parking space. The right turn lane just moves west 1 spot, and then we have some additional space to trade impermeable for permeable surfaces and collect a little bit of stormwater before it goes into the basin. It pipes from a catch basin here to this location. I mentioned performance monitoring, so we are planning on using weirs and flumes along with depth gauges to monitor how much stormwater is showing up in the 2 main basins anymore. So we might find out that, or we might not measure a ton of water most of the time, but that's part of us sort of trying to prove or study how effective GILID can be as part of a flood control solution. We'll also monitor for water quality. I mentioned that the irrigation system collects soil moisture data. We'll test for infiltration. We'll kind of monitor permeable pavers for performance. We have had a graduate researcher from ASU come out with their MARTI card. So MARTI is just kind of a cute name for mean radiant temperature. So they have some instrumentation on a wagon that you pull around the site, and it collects data as you walk around. Pause a few times as you go. So we did it in September. I think we're going to do it again, maybe in a month or so here, and hopefully once more before construction. And then it'll be interesting to compare, do it twice more a year for the next 10 years as the landscape matures, and see how the temperature on site improves over time. And then that kind of goes along with the last bullet point here, where it'll be really interesting to see how all these things work together. So the additional shade cools off the site, which helps other plants grow, which continues to cool off the site, which improves infiltration rates and evapotranspiration. So all of the flood control, heat island mitigation, water conservation work, we hope will just kind of build upon itself once we get the landscape established and working the way we want it to. And that's all I got. So questions, anyone? Or discussion? What do we want to do? Yeah.
Do you have any concern with mosquito poisoning in the parking lot area?
Yes and no. I think the basins on site now are so poorly drained that if there's going to be a problem, it would be there. So, it's a possibility, it's a concern, but I think, especially with the amount of plant establishment that we want, we should see much better infiltration over time.
On the calculation for, how much water is going to be ending up in your basins that exist today,
Yeah.
does that take into consider the amount and types of like trees and plant materials?
It does. We're probably pretty conservative, but in PC Swim, you can plug in evapotranspiration rates. So it's a lump sum model, so you're not, it's not a 3D model of the site. We can't see exactly how water's flowing through the spaces that we're designing, but in the model, you can say, I have a swale that's these dimensions, and we think the infiltration rate is this, evapotranspiration is this. So that's something, I think there's some evapotranspiration monitoring that we could do, which is one of the things on the list that we'd like to keep an eye on after we construct the project, to see if that, or see how that improves as trees grow and establish.
Those permeable pavers that you have over the silva cells, what is the material of the silva cell? I'm assuming they're made for this kind of application. No concern about
Right. Yeah.
dislodging in pavers or differential settlement, or
I believe there's a good number of examples of exactly this, and the subgrade under the silva cells will obviously have to be compacted well. And I think our spec for that is probably even tighter than a typical subgrade compaction for looking out for imperfections. But yeah, no, it's designed for that, so we feel good about it. It's pave drain, 6 or 12 inches of clear stone, and then the silva cells they're plastic, but designed for that. I couldn't tell you exactly what material.
they're low rated for.
Exactly. Yeah. Yep.
And then one more question. Those
Yeah.
10,000 gallon cisterns that are going to be underground, what's the depth? What are the dimensions of those?
So, good question. This is the detail for the ones going off of the admin building. So we have cisterns going essentially here and here, as well as 2 more going here. It's going to be a pretty big hole, so like 10 feet deep. The cistern itself is 6 feet tall. We're in a floodplain here, so there was concern about buoyancy with an empty tank. So there's going to be like a 2-foot concrete slab anchor with a metal strap over the cistern in these 2 locations. So those are going to end up being 12 or 13-foot excavations. We wanted to tuck them up next to the building, but they're going to end up being kind of out in the middle so that we have room to bring those slopes back.
So then that water gets recycled into your irrigation.
Correct. The system is designed, and work urban planning, urban design. Jesse and Brian over there have been really helpful with that, because I wouldn't have known how to design that system, but everything ends up getting run through, referring to it as the mothership cistern is one of the 2 cisterns going here, buried cisterns. So all of it ends up getting pumped to that cistern, and then that cistern will have the control on it, or the connection to the controller, the irrigation controller. So it kind of goes from there.
For the capture of the water that goes into the cisterns, what are you doing for that first flush?
The first flush, I believe these are getting, there's a diverter on the ones coming off the admin building, but in general, it's going to be so clean because it's coming off of rooftops here.
Yeah.
I don't think it's a big concern. There's really fine strainers on the cisterns, and there has to be an air gap, which I think relates more to keeping potable lines safe, kind of a backflow type thing. But I think we've discussed it, but essentially it can be sort of not a concern.
You'd be surprised at the number of pigeons dead pigeons.
Yeah, that's a fair point.
And the amount of dust in the area, that dust builds up in the system over time. And, wow.
Right.
Don't have a foot to it.
Right.
I
I
bring it
believe.
up from experience. of
Okay.
having to do that. So, yeah, that dust is really builds up. It's incredible the amount of dust, particularly in this area.
Yeah.
Well, I guess tacking onto that, we do have pavement areas that will wind up going through that mothership also. don't we? Do the silver cells wind up draining to that cistern?
No, so this kind of mentioned this axis a few times. This will just continue this way towards the parking lot. Outfall will now be a dome drain in. We're gonna tighten up this drive aisle to add landscape here where you see the red outline. So there will be a dome drain there. The water kind of just continues that way. These will only collect stormwater from the only stuff going directly, piped directly to these cisterns is the shade structures.
I think this is a great use of stormwater. And then you had mentioned an education showcase. What does that look like? Is that going to be on site?
Sure.
And is that open to the public, or how are you going to promote that?
We would like for it to reach a lot of different groups. I think professional groups like this is going to be a really important one. But then we have a couple staff members at the district that already do some outreach with K through 12, talking about flood control in general and kind of how all of that works in the desert. So I think we plan on engaging some of those groups. And then I think there's probably some outreach that will happen periodically as we monitor the project itself and some of the data collection we want to do. There'll be outreach there, additional reports, that type of thing. But I think site tours, maybe we'll be able to post some of our findings online, and if folks just wanted to kind of keep track of where we're at with it, that'll be an option too.
I think that's great. Yeah, and you probably want to reach out to the colleges as well.
Yeah,
I think that
yeah,
would
we
be-
work, I mentioned the Marty cart with ASU. There's a potential for a partnership with CAP-LTER, Central Arizona Project, long-term ecological research. So it's a national program that's funded by the National Science Foundation, I believe. And I'm not sure exactly where we stand. We've been talking to them about it quite a bit, but there's a chance that somebody with that group could get funding to make this a long-term study for them, which would be helpful. But regardless, they'll be kind of part of the conversation as far as data collection.
What was your capital budget for this?
We're kind of working without a budget just because, which was great and stressful. But because it's not a typical flood control project, the director has been pretty great about essentially just trusting Harry and I to keep it in check, but also sort of push for what we feel should be reasonable. And so we did a lot of checking ourselves. Some of those earlier reports I mentioned, we did a 20-year life cycle cost analysis to kind of study how the water savings and maintenance savings would hopefully help the project pay for itself over time. And those types of things. We ended up near 2.5 million. That includes the full parking lot replacement at this point, though.
What are the total gallons that you're saving, you know, to get it working to that 1 inch, and what you're using, and if you got a cost?
We've not done the electrical usage of pumps. There's not a ton. There's a few obviously associated with the cistern system, getting that connected to the irrigation, but then irrigation from there is pretty typical irrigation system. Or typical, at least, electricity usage. And sorry, what was the other bit of your question?
Total gallons that you're saving?
Oh, we think it could be around 1 million gallons of water. Probably not year 1, 2, and 3, but after that, it'll be substantial.
That's pretty impressive. I mean, with the tier 1, tier 3, operation.
Yeah.
Yeah, that's pretty positive.
Yeah, thank you.
I like, you know,
Totally. Yeah, exactly. And then the idea that beyond the water conservation, the idea that a neighborhood with flooding issues, if somehow we could promote using dispersed capture and you're doing the water conservation benefits, heat island mitigation, supports all of that, and maybe you're solving a flooding issue without having to go tear a street up and install a pipe.
Okay. Cool. Yeah, thanks for grilling him with all those questions here.
Yeah, that was
You did a good job.
No problem.
A lot of great information. And did we get any questions from
Nope,
anybody
no
online?
questions online.
Okay, so we did enough grilling here, so you're all
All right.
You're good.
Also wanted to see do we have any announcements from McDodd that we'd like to share today? Okay. All right, that makes that easy. And then how about ACEC?
The
Any
only thing we
announcements?
have is Roads and Streets coming up. We will open up exhibitor and sponsor registrations here coming soon. So watch your emails for that if you're interested. And then general registration will open up probably May 1st.
And this is at the same venue
Yes,
as last
so we're
year,
at El
right?
Conquistador, September 28th, 29th, and 30th.
Okay, great. Thank you, everyone, and thanks for that great presentation today.
Well,
Thanks.
You guys didn't want to announce your complete redesign of your parking lot to improve your business? You're gonna let these guys show you up?
we're gonna change.
We're gonna pump your water across,